Okay, now I'm going to explain you about tree diagram. First of all, let's just consider this table. From this table, we can see that if the component of each outcome is only one, where it is just the same case like what we have discussed in chapter 11 book 2, probability of single events. So for each outcome we only have one component, then we can just write the sample space using set notation. So for example, we can see it here, tossing one coin. So if our experiment is tossing one coin, we can just write the sample space as S equals head or tail. So we can see it here. For each outcome, we just have one component, head or tail. And then next, we can see if we have two components, we can represent the sample space by using possibility diagram or tree diagram. But last time we just discussed about possibility diagram. Let's see the example here. Tossing two coins. Let's just try to complete the possibility diagram first. So here we have the first coin, then the second coin. So all the possible outcomes is here. So the first possible outcomes, because this is the first, so we just write it as the first. So this is H, 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 T, and then this one, T. So for the first coin is tail, and the second coin is head, and this is tail, tail. So we can see the total possible outcomes is 1, 2, 3, 4. So and S is 4. Now as we have here, if we have two components, we also can represent the sample space by using tree diagram. So now let's see. If you want to draw tree diagram, just remember that you need to check what is our experiment here. So for this case, our experiment is tossing two coins, which means that we have the first and the second coins. Just write it on the top here. So we have the first and the second coin. And then for the first coin, what is the possible outcome? Because it is a coin, of course, it can be head or tail. So just give space. And then for the second coin, if for the first coin we get head, what is the possible outcome for the second coin? Of course, it can be head or tail, right? And then if the first coin we get tail, what is the possible outcome for the second coin? Again, it can be head or tail. So next, let's list all the possible outcome here, the outcome. So the first, it can be head, the first head, the second head, 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 and then head, tail, head, tail, and then tail, head, and tail, tail. So just the same here, we can see that the possible outcome is 1, 2, 3, 4 equals to 4. So that's if we just have two components. Now what if we have three components? Is it possible for us to write the sample space by using possibility diagram? No, right? Because if the first, let's say the first is here, the second is here, so where should we put the third coins? So we cannot use the tree diagram, right? That's why, the possibility diagram. That's why if we have three components, we can use tree diagram. Let's try to check how to write the sample space if our experiment is tossing 3 coins. Tossing 3 coins. So again, let's check what is our experiment. 3 coins, right? It means we have the first, the second, and the third coins. So let's just write it on the top, the first, the second, and the third. So for the first coin, the possible outcome is only again head or tail, right? So just give more space here. And then let's check one by one. If for the first coin we get head, what is the possible outcome on the second coin? Of course, again it can be head or tail, right? If the first we got tail, the second it can be head or tail. So now we are done with the second coins. Now let's see for the third coin. If the first is head, the second is head. It means for the third coin, it can be again head or tail, right? The same with here. If the first is head, the second is tail, the third it can be head or tail. So let's just do the same thing, head or tail, head or tail. So now let's list all the possible outcome here to make it clearer. So the first we have head, 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 head. It means that for the first coin is head, the second coin is head, and the third coin is head. And then we have head, head, tail, head, head, tail, and then head, tail, head, head, tail, head, head, tail, tail, head, tail, tail, and then T, H, H, T, H, T, 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 H, and then T, T, T. So the total possible outcome is 1, 2, 3, 4, 5, 6, 7, 8. So we have 8.